Okay, welcome back, or for the first time, but I decided to um, make this two different parts so that they were a little shorter. But in the last video of linear inequalities, we took both of these examples and solved them to be in slope-intercept form. So now we have two inequalities that are in slope-intercept form. And what I want to do is show you how to graph them. And if you've already taken the test, you know that I had some extra stuff near the graphing, such as selecting a test point and showing you actually test. So again, linear inequalities, we solved them already to be in slope-intercept form. So go back and watch the other video if you don't know how to do that. And now we're going to graph them. So the first thing I'm going to do is actually just kind of pretend that's an equal sign. I'm just going to kind of ignore it for now. And I'm going to use the y equals mx plus b to know where to start and then how to move from there. So this is my y-intercept. So that means I'm going to start on my graph on the y-axis at 2. So we're just going to scale this by 1 so you don't have to write anything, and there's my 2. Now, this is negative 1/3. Well, maybe I should write down y is 2. And here, this is my slope. And remember, slope is rise over run, and what I'm going to do is I'm going to stick the negative with the 1 in the numerator. Since there's only one negative, it can only go in one place. So this is going to tell us to go down 1, right 3. So down 1, right 3, down 1, right 3. Okay, so now, normally I told you to do this with a pencil, but I have a pen, so I just need to be extra careful before I draw this line. And what I need to be extra careful about is, should this line be a solid line or should it be dashed? So this sign has an equals to. Since it has an equals to, that means we need to do a solid line. Yeah. There we go. And put little arrows on the end. Beautiful. So if there was just an equal sign, this would be the line and you would be done. Unfortunately, the inequality, remember, means that there's many solutions and we need to shade the area where that is. So that's what this is for. This is to tell us where we should be shading. So we pick a test point, and if you remember from the Shade It music video that I showed you from YouTube, it's always best to pick 0, 0 as long as it's not on the line. You should never pick a point on the line. And look at that, 0, 0 right here. So again, the reason we love 0 is because anything times 0 is 0. Okay, so what I'm going to do is rewrite this guy down here because I want to show that I'm testing it. So y is greater than or equal to negative 1/3 x plus 2. Okay, so I'm going to take the y value, which is 0, and I'm going to go ahead and plug that in for y. So 0 is greater than or equal to negative 1/3. And now, instead of x, I'm going to take the x value and plug it in. And that is 0 plus 2. Beautiful. So, now, nothing to do over here. 0 greater than or equal to negative 1/3 times 0 is 0 plus 2. And then 0 is greater than or equal to 2. So, right now, I have 0 is greater than or equal to 2. Well, that's not true. That is false. Okay, so remember, you want to shade to the side that's true. So this side is not true because 0, 0 is false. So I want to double check, did I do everything right? That is indeed 0, 0 plus 2. 0 is greater than 2, that's not true. So that means I want to shade the side opposite. So I'm going to use a highlighter because I got one. And the side opposite is over here, it's the side away. And then there you go. Now I have my graph, and I've showed you that I've done a test point to verify that it should not be on this side, it should be on that side. Again, I've told you if you want to pick a point over here to make sure that it is indeed true. Okay, now on the other side, same thing. We are again going to start by pretending that this is an equal sign just in slope-intercept form, which means my y-intercept is -3. So I'm going to go down here on the y-axis to -3. And again, I'm just scaled it by ones. And then here, my slope, or rise over run, and it's positive, so I don't need to include that. It's 3 over 2. So that means I'm going to go up 3, right 2. Up 3, right 2, up 3, right 2. Okay, beautiful. Now again, before I just draw my line, because I'm in a pen, which means it's going to be permanent, I'm going to look and say, okay, there's no equals to here. It's just a less than sign, which means my line should be dashed. So when I go to draw my line, I'm not going to go crazy and just draw a straight line. I need to make sure that it's dashed because the line numbers on the line are not included, whereas here, numbers on the line would be included in the solution. Okay, so same thing, down to a test. And once you know it, again, my favorite point, 0, 0, is available. So I'm going to take my test point, 0, 0. I'm going to rewrite my inequality again. Y is less than 3 over 2x minus 3. Okay, so again, make sure that you put the y value in for y. So 0 is less than 3 over 2. And the x value in for x. So that's 0 minus 3. So now, and do my math. 3 halves times 0 is 0 minus 3. 0 minus 3 is -3. So now I have 0 is less than -3. Dang it! When you know it, that is also false. Miss Azor, you made 2 false. That's okay. We'll live. Okay. So again, that means that this side, none of these points are going to make this inequality true. So those would not be solutions. These over on the opposite side would be solutions. So again, we want to shade the side opposite of the false. And there you have it. All right. I hope that helps. Good luck.